Okay, class, today we're in lesson 14.1, scatter plots and association. Lesson 14.1, scatter plots and association. Get the section number and title in your notes as usual. Once again, lesson 14.1, scatter plots and association. Key vocabulary for this lesson so far is going to be the word clusters and outlier. Cluster and outlier. A cluster is a set of closely grouped data. Data may be clustered around a point or along a line. An outlier is a data point that is very different from the rest of the data in the set. So an outlier would be a number that's either way below the data you're looking at or way above the data you're looking at. Now, if you notice in the title of this section, they use the word association. Determining association. Association describes how a set of data are related. Association describes how sets of data are related. A positive association means that both data sets increase together. Here is a positive association. Also, a term used is correlation. Positive association or positive correlation. Notice everything is going in the same direction. As X is decreasing, as X is increasing, so is Y. As X is increasing, so is Y. So that's why it's going up in a positive direction. Y is going positive, X is going positive. A negative association means that as one data set increases, the other decreases. So here is a negative association. Here X is increasing, but as X is increasing, the Y values are decreasing. As X is increasing, the Y values are decreasing. So notice X here is small, Y is large. X here is increasing, Y is decreasing. X is increasing and your Y value is decreasing. X is increasing and Y is decreasing. X is increasing and Y is decreasing. No association means that there is no relationship between the two data sets. So if you look here, see how the data is spread all over the place? It's not going in any one direction. So we call that no association or no correlation. Okay, let's take a look at example 1. Susan asked 20 people if they would buy a new product she developed at each of several prices. The scatter plot shows how many of the 20 said yes at a given price. Describe the association between the price and the number of buyers. So here we have our graph. We have the we have the price. And notice how the price is increasing, 0, 2, 4, 6, 8, 10, 12, 14, etc. And notice the number of buyers started at 0 and it goes up to 20. But remember now, these only represent the buyers who said yes. As the price increases, the number of buyers decrease. So there's a negative association. Because the data points do not lie along a line, the association is nonlinear. All right, let's analyze what they just said. So here we have a low price point of $2 and we have quite a few people responding. But as the price increases, less and less people are participating or want to buy at that price point. As the price increases, see at $12, it's always down to 2. Here at $2, it was up to 20. So once again, this correlation is negative. This is a negative correlation. As X is increasing, Y is decreasing.
You know, some data sets can actually be graphed, and we can look at them visually, by means of a scatter plot, where on the axes we just literally put dots that represent the data points. And then we can take a look at sort of how the data fits on the coordinate plane. Let me show you some possibilities for how the data might look. For example, we might see a scatter plot that looks like this. Again, just notice each of those points represents a data point, so each point here. And you'll notice that there's something going on here. In some sense, there's correlation. They're correlated. It seems as though as this object is getting larger, then this direction is getting larger too. The plot kind of was going in this direction. So as this variable changes and gets bigger, this variable is increasing as well. At least that's what the data seems to indicate. And so we say that this is positively correlated. Positively correlated. And it is kind of tight, and it's clear that things are going up as each of these variables increases. And so I'd say this is actually strong positive correlation. Now, take a look at this example. Again, we see this upward trend that as this variable increases, the data also has this variable increasing. So I'd say this is also positive correlation, but not as strong as this. You see the difference? It's kind of, I think so. I call this weakly positively correlated, or weak positive correlation. Here's another potential scatter plot. The data is all over the place. Doesn't seem like there's any kind of obvious correlation like this. Here, as this variable increases, some of the data are big, some data is small. So really there's no correlation here at all. What about here? Well, here there seems to be a slight trend downward. That as this particular variable increases, the other variable seems to be decreasing. So I'd say this is a negative correlation and kind of weak. So a weak negative correlation. And then finally, if we look at this example here, we see that there's a strong tend to move downward. So as this variable increases, this variable seems to be decreasing. So this would be a strong negative correlation. Going down negative, going up positive, and everything in between. Let's take a look at an example together. So we're going to be given a table that shows the number of runs scored by a softball team in the first 7 games of the series. And so now here's our challenge. To use the given data to make a scatter plot, and then to look at the scatter plot and try to describe if there's any correlation there at all. So let's give this a shot right now. So here is the table. You can see the first 7 games, and this is the number of runs scored. The first game, there were 3 runs scored. Second game, there was 1 run scored. By the seventh game, we had 12 runs scored. So these are linked like that. And if I think of this as x comma y, we can actually graph on a coordinate plane what we see. And I want to do that right now. And I want to do that live. That's right. I'm going to do it in front of you right now. So on this x-axis is the game number, and then on the y-axis we have the number of runs scored per game. And we're now going to create this appropriate scatter plot by just plotting these points. So game 1, we have 3 runs scored. That means 1 comma 3. X equals 1 game, and then y equals 3. So 1 comma 3, 1, 2, 3. I put a dot right there. First dot of my scatter plot. Then 2 comma 1. 2 comma 1. Then 3 comma 5. So 3, and I go all up 4, and I go up 1 to 5. And then 4 comma 9. So at 4, we have 9 runs scored. That's right between 8 and 10. And then at 5, we have 12 runs scored. Wow, so at 5, there's all the way 12. That's 10, 11, 12, way up here. And then at the 6th game, we scored 10 runs. So 6th game, we have 10 runs. 10, 6, 10. And then the 7th game, we had 12 runs. So the 7th game, we have 12 runs, and we stop. This represents the scatter plot for this particular data set. Now, is there a correlation? Well, if we look at it visually, there definitely seems to be this upward trend. I'd say this is, in fact, positively correlated. Because as the number of games increases, the number of runs scored seem to increase as well. Is this reasonable? Absolutely, right? In fact, you might expect this. The more games you play, of course, the more practice you have, and therefore the better you become at it. And that's what this data set is articulating, and in fact, we're seeing it visually through a scatter plot. So it's kind of cool that even baseball allows us to, even looking at scatter plots and math allows us to understand even baseball better. So here we go. Let's try it again. Let's see. That was a foul. That's called a foul here on the studio. Nice. There's a good one. And I broke all sorts of equipment. But the point is that you can see in the real world, by looking at data, in this case through a scatter plot, we can see correlation.
Okay, now let's look at the data in a little bit more detail, and let's make sure that you know how to graph. All right, now, game, do you notice how the word game is on the x-axis? And y, runs, is on the y-axis. So that means that this is your x value, this is your y value. X, y, x, y, x, y, x, y, x, y, and x, y. So when you graph, the first thing on the graph is x is 1, that's there, and y is 3. 1, 2, 3. That's that point. Next you have x is 2 and y is 1. So x is 2, 1, 2, and y is 1. That's 1 right there. So x is 2 and y is 1. Next you have x is 3 and y is 5. So 3, 1, 2, 3, and y is 5. 1, 2, 3, 4, 5. That's 5 right there for y. X is 3, y is 5. Next we have x is 4. So 1, 2, 3, 4. And y is 9. So we go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Next you have x is 5, y is 12. X is 5. 1, 2, 3, 4, 5. And y is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next, we have the x is 6 and y is 10. 6, 1, 2, 3, 4, 5, 6. Y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And last but not least, x is 7 and y is 12. 1, 2, 3, 4, 5, 6, 7. And then we get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And with that, we graphed our points. Now we can see what kind of correlation it is. So that word correlation. And you can see almost all the data is going in a positive direction. Almost all the data is going in a positive direction. So as the number of games played increases, the number of runs scored also increase. Once again, as the number of games played increases, the number of runs scored also increases. All right, let's get the key objective in your notes. Learn to create and interpret scatter plots. And also let's get these definitions. A scatter plot is a graph with points plotted to show a relationship between two sets of data. A scatter plot is a graph with 2 points plotted to show a relationship between two sets of data. Correlation describes the relationship between the two sets of data. Correlation describes the relationship between the two sets of data. That is, positive, negative, or no correlation. Once again, positive, negative, or no correlation.